Alright, hello, this is Mr. Crozier. We're going to do some more vector operations, mainly dealing with the concept of scaling, and we'll talk about that. Alright, let's talk about it in terms of a triangle. We have this triangle here, and there's a couple things we could do with this triangle. It's a right triangle, 6, 8, 10, Pythagorean triple. We could take this triangle and we could scale it up, multiply it by 2, and get this much larger triangle. Now, the scaling here is not correct, but you got the idea. And the sides are now 12 and 16 and 20, and everything's the same about this triangle. This angle matches this angle, and this angle matches this angle. It's just a larger version. Alright, we could take this same triangle and we could divide it by 2 or times it by a half, and we have this smaller triangle now that is 3, 4, 5. And again, this angle matches. The angles don't change, just the size, and that's what we mean by scaling. We've changed the scale of it. And we could do one last thing. We could take this triangle or any other one, and if we divide it by 5, the interesting part about this triangle is now it's much smaller, but the unit part of it, the hypotenuse part, is 1, just like the unit circle. So this is 3/5, and this is 4/5. But again, the angles didn't change. They should be all the same. Alright, what we want to do is think about these now in terms of vectors. Instead of a triangle, it's a vector that starts here and goes up, and it's a vector that starts there and goes up, and they're all vectors that go in that direction. And this one is called the unit vector, because the vector has a length of 1. They're all the same. They're all the same direction. They're all the same angles. This is the unit vector because this magnitude, the length of the vector, has been brought down to 1. So we're going to practice that today. We're going to take vectors and we're going to make them bigger or smaller sometimes, and we're going to put them in the unit vector, which means the magnitude is just 1. The magnitude is the length. Alright, here we go. So here's an example. Part 2, find the unit vector. So we're trying to find this vector up here where the length of it is 1. Alright, well, first problem, well, we're given the vector and the vector is 5, 0. Well, if you don't know what that is, it's always a good idea to draw it out. It's a vector where it's 5 in the x direction, 1, 2, 3, 4, 5, and nothing in the y direction. So this is our vector, or triangle, but in this case it's a triangle with no area here. It's 5 right now, but we want to drop it down to a unit vector, so we're going to divide everything by 5. And here's our notation. We're going to put this little upside down V on it and say this is a unit vector. It's a U. The word is a hat here. It's called a hat. The U hat is this vector divided by 5, so we have 1, 0. And that is a unit vector that matches that vector. Same direction, right? 1 this way, I could draw it right here, it'd be right there. Same direction, just 1. Alright, it gets a little bit more complicated over here. Let's see here, we have this vector, and what is that vector? Let's see, let's draw this. 1, 2, 3, 1, 2, 3, 4, 5. There's the vector 3, 5. Well, we want to narrow this down so that length is only 1. Well, right now the length is what? A squared plus b squared, that'd be 9 plus 25. Right now the magnitude of this is root 34. But we want to scrunch it down so it's only 1. So we're going to take this and divide everything by root 34. So we're going to take everything up here divided by root 34. So my new vector is, let's see here, 3 divided by root 34 and 5 divided by root 34. Those are good answers, but we're not going to leave these radicals in the denominator. Whoops, let's put a little hat on this one to say it's a unit vector. And what would that be? 3 root 34 over 34 and 5 root 34 over 34. This is the vector. This is the scrunched down vector, so it's only 1. So it's only 1, so it's somewhere right in there. Same direction. This vector and this vector, same direction, just smaller. All right, and the vector here, well, we know this notation. This notation is simply 4, negative 5. And we're just going to divide that down by the magnitude. Well, what's the magnitude of this? A squared plus B squared would be 16 plus 25. We're going to divide it down by root 41. So can you do that math in your head? It would be 4 root 41 over 41 and a negative 5 root 41 over 41. All right, let's go ahead and put it back in the, whoops, I kept forgetting to change the symbol here. Let's go ahead and put it back into this notation up here. So we have 4 root 41 over 41 I minus 5 root 41 over 41 j. And that just means I direction, j direction, which is simply the x direction and the y direction. All right,